Hi friends, we are going to see another problem. A person's reaction turbine while running at 400 rpm consumes 30 tons of steam per hour. The steam at a certain stage is at 1.6 bar with dryness fraction of 0.9 and the steam develops 10 kilowatt. The axial velocity of flow is constant and equal to 0.75 of the blade velocity. సో ఇక్కడ గుర్తుపెట్టుకోండి, బ్లేడ్ వెలాసిటీ వచ్చేసరికి 7.5కి ఈక్వల్గా ఉంటుంది ఫ్లో వెలాసిటీ వచ్చేసి. ఓకే, మీన్ డయామీటర్ ఆఫ్ the drum and the volume of steam flowing per second. Okay, take blade tip angles at inlet and exit A as 35 degrees and 20 degrees respectively. This problem is look like as it is in same similar in previous we solved. So but here we are going to find the diameter of the blade. Okay, now we are going to see how to solve. Now here we are going to solution, and here given written here given the speed of the turbine is n is equal to 400 rpm and 30 ton per hour, that is equal to 8.33 kg per seconds. P is equal to 1.6 bar is coming from pressure, and now we go for x is equal to 0.9. This is a dryness fraction. This P is called for power. Okay, that is equal to kilowatt, 10 kilowatt. Now that is 10 into 10 to the 4 cube watt. And now we go for flow velocity is equal to blade velocity. So then blade velocity you take here 25 meter per seconds, and theta is equal to beta, both are same in 35 degrees, and pi is equal to alpha, that is equal to 20 degrees. Okay, now I am going to draw the velocity diagram for this. We know very well how to draw the velocity diagram. Okay, first we draw one straight line with blade velocity 25 suitable scale, and then take here 20 degrees. I put here C. This is 20 degrees, then this is coming from 35 degrees. One vertical, one horizontal. This point you take E, and again you take 20 degrees in here, and then here you draw 35 degrees. Okay, then here draw one straight line. So this is D, this is F. Now we know very well this is V, this is VR, this is Vf, and take this is V1, VR1, Vf1. This is coming from VW, this is VW1. Okay, so now this is the velocity diagram. So we need to find here VW and VW1. Okay, so we are going to solve the problem now. First we are going to solve all velocities. Unknown velocities is there, Vf, Vf1. We need to find out here Ea distance and Bf distance, so that we can write down here Ea is equal to Bf. Okay, the distance is equal to this. Why? Because same angle. Okay, now we need to find out Ea. Ea find out means we need here F1 and Vf and Vr. At the same time velocity V also we should know. Okay, now and this value also be find out from the geometric the velocity diagram. Okay, this value may be found out from the geometry of the velocity diagram. Okay, so Vf is equal to V sine 20, that is coming from V. This is triangle BCE. Okay, next Vf is equal to VR sine 35 degrees 0.576 VR. So this is coming from triangle ACE. Okay, now similarly 0.3240 V is equal to 0.5736 VR, or V is equal to 1.77 VR. Okay, and now we go for VW, real velocity. VW is equal to VR cos 35 degrees plus 25. Okay, and then that is equal to, you can solve some relation with here 80, and then now here 0.9397 V is equal to 0.8192 VR plus 25. Then 1.663 VR is equal to 0.812 VR plus 25. Sorry, here I missed one step, I think. Okay, so substitute this V is equal to V is relative of VR. So now this value, okay, here is substitute this value, will get this 1.663 VR. Okay, V బదులు ఈ వాల్యూని మనం ఇక్కడ సబ్స్టిట్యూట్ చేస్తుంటే మనకు టోటల్గా ఈ వాల్యూ వస్తుంది 1.663, and then we go for 8483 38 VR is equal to 25, or VR is equal to, the calculate this thing, we will get VR. Okay, it approximately it will come, for example, I take here, calculate this, you get 34.8 something, I think. Okay, but it's not exact value. Okay, remember, it's not exact value. And EA is equal to VR cos 35 degrees. So now that is equal to 94.8 into 0.8192 is equal to 77.7. Then VW plus VW1. So this is equal to EA plus AB plus BF. Okay. Now then calculate here, EA is equal to 77.7 plus 25 plus 77.7. Why? Because EA is equal to BF. Okay. Then here we can find out 73.5 mm approximately. Okay. Good. Now this is the calculation of VW plus VW1, and then we go for here VW plus VW1. For example, sometimes this here blade velocity is not given. Example, blade velocity is not given. Then how can we find out blade velocity? Now here we see that thing, VW1 divided by VB, that is equal to 73.5. 25 is equal to 2.94. Now here VW1 plus V, this is the equation. Now we can take here VB. We know that the power developed, okay, we know that the power developed P. So then here 10 into 10 cube, that is equal to M into VW plus VW1 into VB. So then here 8.33 into 2.94 VB into VB is equal to 20.2 meter per seconds. Sorry, not 20. Okay, here 24.99 VB. Okay, right. So now then here VB square is equal to, therefore VB square is equal to 408.3, or VB is equal to 20.2 meter per seconds. Okay, so we know that the blade velocity VB, blade velocity VB 20.2 is equal to pi d n by 60. Then pi d 400 divided by 60, that is equal to 20.94 d. So then d is equal to 0.965 meter, that is equal to 965 mm. Okay, this is the diameter of the blade. Now we go for calculate volume of steam flowing per second. Volume of steam flowing per second. So then from steam tables corresponding to a pressure of 1.6 bar, we find that specific volume of steam that Vg is equal to 1.091 meter cube per kg. So therefore volume of steam flowing per second, so that is equal to m into Vg. So m is equal to 8.33 is given, 0.9 into 1.01. So calculate this, you will get approximately this the value. This is seconds. Okay, right? So this is the answer. Okay, and then we will see some more problems in next class. Okay, thank you.